Hello and welcome to the Chemistry Solution. This tutorial is on ionic equations, net ionic equations, and spectator ions. In solution, strong electrolytes exist predominantly as ions rather than molecules. And in ionic equations, we write these compounds as ions rather than in their complete chemical formulas. The reaction silver nitrate plus copper chloride reacts to give us silver chloride plus copper nitrate is written here as a molecular equation. To write an ionic equation, we need to separate any soluble, strong electrolytes into ions. We can determine that a compound is a soluble, strong electrolyte by the abbreviation AQ for aqueous in parentheses after the compound. If this information isn't given to you, you would need to determine the solubility of these different compounds on your own using a table of solubility guidelines. However, in this example, we know that silver nitrate, copper chloride, and copper nitrate are all soluble strong electrolytes, and we can separate these compounds into their ions. This gives us a new reaction written as follows. And we term this new notation of the reaction a complete ionic equation. You can also remove any ions that are the same on both sides, and we call these ions that are the same on both sides of the equation spectator ions. In this example, you'll see that we have two nitrate ions on each side of the reaction arrow and one copper ion on each side of the reaction arrow. These would be our spectator ions. We can then omit these spectator ions when writing the final form of our equation. 2 silver ions plus 2 chlorine ions gives us 2 silver chloride. This equation is known as a net ionic equation. Let's try an example. Write the ionic and net ionic reactions as well as identify the spectator ions for the chemical reaction written below. In this example, we can identify the soluble strong electrolytes by the aqueous abbreviation written after each compound. Once again, you could also determine the solubility of these compounds on your own using a table with solubility guidelines. We'll begin by separating the soluble strong electrolytes into their respective ions. This gives us our ionic equation. We can then cancel out any of the ions that are the same on both sides of the reaction arrow. And these would be our spectator ions. When we cancel our spectator ions, we can now write our net ionic equation with the ions and compound remaining. And here's our completed net ionic equation. Thanks for watching the Chemistry Solution.